Symmetry in two dimensions. Symmetry means that one shape becomes exactly like another when they are rotated or when they are reflected by a mirror, or both at the same time. For two objects to be symmetrical, they must be the same size and shape. There are two types of symmetry in 2D shapes: reflection symmetry and rotational symmetry. Reflection symmetry. Reflection symmetry occurs when a line is used to split a shape in halves so that each half reflects the other half. The line of symmetry is the line which divides the figure into two mirror images, and to determine if a figure has a reflection symmetry, fold the figure along the supposed line of symmetry to see if the two halves coincide. Examples. On the shapes, draw the lines of symmetry. Square. This is a line of symmetry. This is a line of symmetry. The diagonal is a line of symmetry. Another diagonal. Four lines of symmetry in a square. Rectangle. This is a line of symmetry. This is a line of symmetry. In a rectangle, the diagonal is not a line of symmetry because if you fold the figure along the diagonal, you can see that the two halves do not coincide. The line will be line of symmetry when the figure is folded across that line so that one half of the figure will coincide with the other half. Isosceles triangle. This is a line of symmetry. One line of symmetry. Parallelogram. This is not a line of symmetry because if you fold the figure along the line, you can see that the two halves do not coincide. This diagonal is not a line of symmetry because if you fold the figure along the diagonal, you can see that the two halves do not coincide too. No lines of symmetry in a parallelogram. Let's see how it works. Complete the figures below by drawing the reflection over the line of symmetry in red. Remember, the line will be line of symmetry when the figure is folded across that line so that one half of the figure will coincide with the other half. Rotational symmetry. Rotation turns a shape around a fixed point called the center of rotation. A figure has rotational symmetry if when rotating, turning or spinning the figure around a center point by less than 360 degrees, the figure appears unchanged. It still looks the same. The smallest angle of rotation that maps a figure onto itself is called the angle of rotation or angle of rotational symmetry. It is greater than 0 degrees but less than 360 degrees. Example. Let's check how many times an equilateral triangle fits onto itself during a full rotation of 360 degrees. An equilateral triangle does have rotational symmetry. It can be turned 120 degrees clockwise and will still look exactly the same. (120 degrees is the angle of rotation to the equilateral triangle. The order of rotational symmetry of a geometric figure is the number of times you can rotate the geometric figure so that it looks exactly the same as the original figure. The equilateral triangle has order of rotational symmetry of 3 because you can spin the equilateral triangle 3 times so that it looks like the same. It took 3 rotations to get back to the original position. The angles of rotation in a equilateral triangle are 120 degrees and 240 degrees. The angles of 0 degrees and 360 degrees are excluded because they represent the original position. Nothing new happens. Determine whether each figure has rotational symmetry. If so, identify all the angles of rotation less than 360 degrees. Let's check how many times a square fits onto itself during a full rotation of 360 degrees. The order of rotational symmetry for any square would be 4, because it took 4 rotations to get back to the original position. The order of rotational symmetry for any parallelogram would be 2, because it took 2 rotations to get back to the original position. The angle of rotation is 180 degrees. Pay attention now. The order of rotational symmetry for any shape like this would be 0. It has no rotational symmetry because it took 1 rotation to get back to the original position. Order 1 implies no true rotational symmetry exists.